Now, good morning, dear 10th class friends. Now, today, first we have to study about the mirror formula. Okay. So, what is the mirror formula? Look, and you have to write also. Mirror formula. This is 1 upon V plus 1 upon U is equal to 1 upon gamma. Here it is U is equal to object distance V is equal to image distance and F is equal to focal length. Okay. So when we will solve some numerical problems, then we have to need of this mirror formula. Okay. So this is the mirror formula, and it is just showing the. Okay. This is showing relationship between focal length object distance and image distance. So mirror formula is just showing only the image distance. It means the relationship between the image distance, object distance and focal length. So now we are just introducing one new Cartesian sign systems. Okay, new Cartesian sign systems. So this is the sign conventions. That is the new Cartesian. Okay, through that we have to see that how we can put the negative or positive. It means how we have to take the negative and positive values of object distance, focal length and image distance. Okay, so this is the pole. All distance should be measured from the pole. Okay, so you have to write first point for here. All distance taken from the pole. Okay, so all distance is taken from the pole. It means if there is an image, then we have to take the distance from the pole, and we have to measure a image distance or object distance from the pole. Okay, then next point is in the incident light propagation values will be positive. Okay, so the direction of incident is like that. Okay, so this is incident light. Okay, propagation. So all values which is in the direction of incident light. So all in the incident light propagation values will be positive. Values will be positive. Okay. Values taken for object always negative because due to opposite direction of incident light. Values for upward and perpendicular to means principal axis will be positive. Will be positive. Okay, it means values for upward and perpendicular to the principal axis will be positive. Next is values downward and perpendicular to principal axis will be negative. And values for will be positive, and values taken for object always negative because due to positive directions. Okay. Okay. So I think enough. This is okay. So look at so this is the new Cartesian sign convention systems. It means how to we have to it means the categorize the values for the object distance, for the image distance, and for the focal length. So look at here. If it is a surface, it means the reflecting surface of the concave mirror, then if we are getting the values of, it means if we have to put one object is here, okay, look that this is a one object, it means we are keeping here, then values we have to taken always from the pole of the mirror, then it will be always negative, it will be the always negative, it means the object distance will be never positive. Okay, object distance will never be positive because always object distance will be taken from the pole, and it is the opposite sides of opposite direction of incident light. That's why it is always be negative. Okay, so first of all values are in the respect of this incident light, and this incident light is in the form of in this way. Then if the distance, maybe the image is just behind this concave mirror, then we will take the values will be the positive. Okay, so if distance we have to measure behind the mirror, then it will be the positive, and before the mirror, it is the front of the mirror, then it will be the negative. Okay, and object always we have to keep on the principal axis. Okay, object you have to write also if you want to, then object always kept at principal axis. Okay, it means object always at principal axis, then height of the object, and height of the object never will be the negative. So height of the object always positive. Height of object always positive. You know about that because if there is some material, they can be made up of any matter, and any matter having a many microscopic size also. So there is a no negativity in the height of the object. Okay, so height of the object always positive. Okay, height of the object always positive. So if a minute particles also having a some size, that's why we have to give on the upside of this principal axis. Okay, and on the perpendicular, so the perpendicular height of the object is always positive, and if some image can be made in the front, but they will be the always from downside, okay, then their size will be the negative, their size will be the negative. It means if the height here, it means categorized from this principal axis, then upside it will be the positive, downside and it will be the negative. Okay, and distance is always from the P pole it will be the negative because due to the opposite sides, opposite direction of incident light, and from the P the positive direction, it means the direction of incident light. That's why we have to take only the positive value of these directions. Okay, so I hope you are understanding these things. Now next thing is you have to write simultaneously. Okay, not understanding then you have to ask. Okay, after that. One more thing we have to study here, that is the linear magnification. Okay, height of object, height of image. You already knows about that object distance, and this is the image distance. Okay, so this is the M, it means the linear magnification, h2 upon h1 or minus v upon u. So u is the object distance, v is image distance, h1 it means height of object, and height of image. It means if we know any height of object or height of image or maybe the magnification, then we have to it means to calculate the magnification also. It means in from these three values if we know anything, and from these three values if we know anything, two values if we know, then we have to calculate the one more values. Okay, so we will see that if the linear magnification is 1, then the same size of the object and height, okay, and less than 1, then there is maybe the changes in between the height or distance of the object and image. Okay, so first we have to write, there is no enough place to write here the rules for convex mirror, that's why you have to write first this one. Okay, now dear students, we have to see and study about the rules for obtaining images for the convex mirror. So you have to write what are the main rules. Rules for obtaining images for convex mirror. First thing, a ray of light which is parallel to the principal axis after reflection appears to be coming from inside the mirror. Okay. Look, the diagram is coming from focus. Okay. Which is inside the mirror. Okay, you have to understand here. This is incident light. This is the principal axis. Okay. And this is your focus. Okay. So now you should know about that. This is the virtual focus here. Okay. So light will be the coming from the focus of a mirror. Okay. This is the incident light. Now the second one is a ray of light which is passing from center of curvature after reflection along same path. Okay, so you have to know about that. Third one is a ray of light which is going towards principal focus after reflection will be the parallel to principal axis. Okay. A ray of light which is directly incident to reflected with making same angle with principal axis. Okay, reflected with making same angle with principal axis. Okay, and now we have to study about the rules of this convex mirror. Okay. Object and infinity. Object is in between the infinity and P, so image will be formed within the focus. Okay, and object at infinity, then image diminished, and this is highly diminished and virtual and So look, first we have to describe about the rules for obtaining image for convex mirror. Okay, concentrate here. Okay. So a ray of light. Okay, look everyone here. Stop writing. A ray of light which is parallel to the principal axis. Okay. So this is the ray of light which is parallel to the principal axis. Now you know about that. This is the principal axis which is passing through the poles. Okay. We are here describing the nature or with the images for the convex mirror. Okay. Then after reflection appears to be a coming from focus, which is inside the mirror. So after reflection, so this is the ray which is after the reflection. So coming from the focus of a mirror, and that focus is the inside the mirror in the convex sense. Okay. A ray of light which is passing from center of curvature. Okay. A ray of light which is passing from center of curvature after reflection come along same path. Okay. So this is the center of curvature light. Okay. And after the reflection it is coming the same path. Okay. And now you know about that. Why we are showing this in this manner, because look, if like that it is the spherical surfaces, then this is the light where the center of curvature means the center of the sphere. Okay. Now a ray of light which is going towards the principal focus. Okay. So this is the incident light which is directly to the principal focus. Okay. And after the reflection it will be the parallel to the principal axis. So after reflection will be the parallel to the principal axis. A ray of light which is directly incident to pole. Okay. So this is the pole and directly incident to the pole. So with making same angle, to I with R. Okay. To I with R, it is the angle of incidence and angle of reflection. Reflected with the making same angle with the principal axis. Okay. And now only two cases can be formed with the convex mirror. So object position anywhere. It means anywhere in between infinity and P. It means anywhere we have to keep the object in infinity and between P. Then image is at within the focus. It means just inside the focus will be formed. Diminished image will be formed. Virtual and erect will be formed. And if object is at infinity, then image is at F and highly diminished. It means very small image will be formed at focus. Okay. Then virtual and erect will be shown. And now for two uses we have to write here. Okay. Anyway, we have to write these. They are the today we are now studying about the uses of convex mirror. No much more uses can be used for that, but two uses to see the rear view. Okay, to see the rear view in vehicles. Okay, anywhere it is the truck, car, buses, okay, motorcycles, anything. So to see the rear views in vehicles. Okay, now. Second, it's used in shop security mirror. Okay, shop security mirror. So I hope you understood all these things. Okay, and you have to write now.